let's talk about exponential functions. So an exponential function is a to the x power, where a is the base and x is exponent, and a is greater than 0. So let's take an example of this. 2 to the third power. Well, that's 2 times 2 times 2, which is 8. So it's like a number being multiplied over and over. Okay, let's look at the domain and the range of the function. Well, x is a subset of r. So it's anywhere from negative infinity to infinity. Well, y, which is ax equals y by the way, y is anywhere from 0 to infinity. Okay, so let's look at the graphs. Suppose a is less than 1 but greater than 0. Let's look at the graph. Okay, notice that when x is 0, it's at 1. When x is greater than 0, it goes down and down. When x is less than 0, it grows very fast. Okay, let's look at when a is greater than 1. Okay, again, when x is 0, it's 1. But it quickly increases. But when x is less than 0, it decreases very quickly as it approaches 0. Well, let's make a table of values for a to the x. Let's do the first example. When a is less than 1 but greater than 0, let a be half. Then it's half of x. Yeah. So let's look at a table of value. Let's start from negative to positive. Let's suppose it's negative 5. Well, that's half to the negative 5 power, which same thing as saying 2 to the negative 1 times negative 5, which is 2 to the 5, which is 32. Okay, negative 5 is 32. Negative 1 is, well, half to the negative 1 is the same thing as 2. 0 is 1. 1 is half. 5 is 1 over 32. Notice it grows really big when x is less than 0, but when x is greater than 0, it really shrinks. Now let's look at example when a is greater than 1. Okay, then a equals 2. Then it's 2 to the x. Let's make a table of values, x and y. Negative 5. Well, that's 2 to negative 5. That's 1 over 32. Negative 1, well, it's 1 half. 0 is 1. 1 is 2. 5 is 32. 10 is 1024. So notice it grows really big when x is greater than 0, and it shrinks when x is less than 0. Now let's talk about the properties of a to the x. So the first property is a to the x plus y power. That's the same thing as a to the x times a to the y. Let's look at an example. 2 to the 3 plus 4 power. Okay, that's the same thing as 2 to the third times 2 to the fourth. Well, that's the same thing as 2 to the seventh. We can verify this by doing, 2 to the third is 8 times 16, well, that's 128, right? If you do 2 to the third plus 4, which is 2 to the seventh, You also know this is 128, so they're equal. Conversely, a to the x minus y, same thing as a to the x divided by a to the y. Let's give example. 2 to the 5 minus 2 power, same thing as 2 to the 5 divided by 2 to the 2. Well, 2 to the 5 is 32 divided by 2 to the 2, which is 4, which is 8. Notice 2 to the 5 minus 2 power, same thing as 2 to the 3rd, which is also 8. So you see it's the same answer. Another property is when a to the x is taken to the nth power. That's the same thing as a to the x times n power. Example, 2 to the 3rd to the 2nd power, same thing as saying 2 to the 6th, which is 2 to the 3 times 2 power. Okay, so let's do an example problem now. Suppose 2 to the x is 6. So find 2 to the 3x minus 1 power. Notice that 2 to the 3x, the same thing as 2 to the x to the 3rd power. Well, that's the same thing as 6 to the 3rd power. Well, then 2 to the 3x minus 1, the same thing as saying 2 to the x cubed times 2 to the negative 1, since we use the property separating them, right? From before. And we can substitute 2 to the x for 6. Then it is 6 to the 3rd power times 2 to the negative 1 power. Well, that's the same thing as saying 6 times 6 times 6 divided by 2, which is 216 divided by 2. Well, that's 108. So that's 108. That's the final answer. Well, enjoy.